Good morning, everyone. So far, we have seen discussion on the front-end design of the compiler, and now we are moving to the back end of the compiler. Actually, not even the back end of the compiler, what is called as the middle end of the compiler. So modern compilers, so you can, they are kind of uh, divided into, you can say, so you will have a front end, and you'll have a middle end. So this word sounds a bit like an oxymoron, but and then there is a back end. What I'm writing is not visible. Huh? Let me see clear. How about now? Is it visible? No, we cannot see what is being written. What to do? How about now? Is it? Can you see now? Great. Yeah, so I just read it the whole thing. I don't know the reason, but anyway, thank you. So as I said, so the modern compilers, they have a front end, and there is an optimizing middle end, and then there is a back end. And so far we have been, we looked at how to design the front end of the compiler. So if you take a simple compiler, uh, then in that simple compiler, you may not have this middle end. Essentially, you will have the front end. In the front end, what happens is you do, like lexical analysis, syntax analysis, followed by semantic analysis will happen, and an abstract syntax tree will be generated. From the abstract syntax tree, it is possible to generate machine code directly. So that makes the compiler simple, but the generated code, but the quality of the generated code will not be good. So in order to improve the quality of the generated code, that means in order to make the generated code run faster on the target machine, we have to introduce many optimizing passes in the middle end of the compiler. So if you see the structure of an optimizing compiler, which is the case for all modern compilers like GCC, LLVM compiler, or Intel ICC compiler, if you take any of these compilers, so after the front end, so this is where the front end ends. So after the front end uh, is over, the front end generates a high level intermediate representation. It could be an AST, or from AST it could generate to a different kind of linear intermediate representation. AST is a tree structure intermediate representation. And this intermediate representation will be passed to through a series of machine independent optimizations. And then we get the optimized IR here. At this point, we get optimized IR. And if you look at these machine independent optimizations, so these machine independent optimizations, some of them they can work on abstract syntax tree, and some of them they may work on a lower level linear IR. So both are possible. Some optimizations such as function inlining, etc., I think they are better done at the AST level, or even certain loop transformations, they are better done at the AST level. And there are many other optimizations which are better done after the AST is lowered to a linear intermediate representation.